idea is not the newest idea, and maybe not the most original idea, but it was something that I was interested in. And my question is, why would someone want to invest in gold, and does the investment in gold still pay off, and is it still a smart investment idea? So I'll go with the short introduction. Then what I'll be speaking in my paper about is gold in general, the different kinds of gold, etc. My analysis, the hypothesis, and my conclusion. So what is the paper about? My paper is about if there are so many different investment possibilities where I can try to make monies with all the strategies and portfolios I could run, is investment in gold still a good idea? Does it still pay off? And the literature I used was mainly from just investment literature, especially focusing on security issues, and in addition some analysis about current crisis and historical crisis. It was mainly taken out of academic research, papers, essays, etc., where I had access to through the university network of my home university. So where are the upsides in gold investment? The big positive sides are they can be used as a hedge against crisis and inflation. Gold is very fungible and homogeneous. That means you have a 24-hour market. You can always buy it, get rid of it. It's very homogeneous. It has the same value in every country. It doesn't differ, etc. It is discrete. It is stateless. It's not depending on any situation in any state, instability, etc. And it is mobile. You can just take it and get it wherever you want to, whatever area. You can choose your safety post, etc., how you want it. The big downsides, of course, are right now there's a pretty high gold price, and gold is vulnerable to manipulation from banks, etc., that can steer demand and supply, and therefore tinker with the price a little bit. And there, even though it is said that gold has a completely static value, more or less, the purchasing power did change historically over time. So what I am talking about in the paper is the risk or the safety issue. What is the more important part? And concerning this, the question is if you're rather pessimistic, a moderate, or an optimistic investor, and therefore the hypothesis is the riskier other investments appear, the more investors flee to gold, and therefore through the increasing price, gold remains a smart investment. Or, that is the second step of the hypothesis, that the more risk averse as an investor you are, the higher the incentive for you is to still invest in gold. And that is basically my conclusion in the paper, that no investment offers those advantages that I mentioned before, and historically proven it is still a decent and relatively constant return on investment, even though it might not be the highest investment return you can get. It always has proven to offer a constant return on the gold investment. And gold is just was always and will always be something special, whether you invest in pure gold, in gold paper gold, or even in jewelry. It is just something special and will always work as a currency or something of value that you can keep value in, and it still remains the probably safest investment asset available. Thank you very much.
My research paper question is about Fed model. The Fed model is a theory of comparing interest rate of long-term treasury notes and expected return from stock market using PAR. The Fed model is long-term treasury bond minus 1 divided by PAR. The Fed model shows a relationship between long-term treasury notes and the expected return on equities. The value of Fed model is long-term treasury. The PAR is price per share divided by annual earning per share. Fed model is used when deciding to enter the stock market. If the value of Fed model is higher than 0, it is better to invest on treasury notes instead of stock market. On the other hand, if the value of Fed model is lower than 0, it is better to invest on the stock market instead of treasury notes market. So my proposition is that I decide when I invest on the stock market and selecting the stock which has high correlation with entire stock market. Finally, I will check how much I can gain the profit from this method by comparing interest rate of long-term treasury notes. In market equilibrium, expected yield of bond and stock market will go same level. So earning per share divided by price per share. If earning per share divided by price per share is larger than bond rate, it means stock market is overpriced. And on the other hand, if earning per share divided by price per share is lower than bond rate, it means stock market is underpriced. So we can decide the time when we invest on the stock market, and if we select the stock which has high correlations with the entire stock market, the individual stock will be likely to follow the entire market. Let me check return on the stock. I use data daily 5-year Korean Treasury bonds rate. In theory, 10-year Treasury bonds rate should be used, but I can get that, so I use the 5-year one. I get this data from the site of Bank of Korea. And I use the daily PAR of KOSPI from KRX site. I could get Fed model value from these two data. And I use daily fluctuation rate of 3 stocks: SK Telecom, Samsung Electronics, POSCO. And KOSPI from KRX site. This is because those 3 stocks have high correlation with KOSPI. From this fluctuation rate, I could choose the stock has high correlation with KOSPI. Whole of data is from 2001 October 22 from 2011 May 27. Firstly, after I compare the 3 stocks daily fluctuation and KOSPI's daily fluctuation, and I choose Samsung Electronics. The correlation between KOSPI and Samsung Electronics was 0.77. The highest value of 3 stocks. The next step is getting the value of Fed model. The top 25% value of Fed model is minus 4.3209. So I decided to invest on the Samsung Electronics when bad model value is lower than minus 4.3209. So from this I choose 4 period from 2001 to 2011. In first period, suppose that I bought one stock at 287,501 and sold 545,001. From this, return rate was 98.18%. This from testing these 4 periods, in conclusion, the method shows relatively high return, but there was a limitation. This is because the lower value of bad model doesn't always mean high return of stock. So its value is not absolute and should utilize as assistance index. In addition, a stock has lower correlation with Kospi. It cannot be used.
Again, let me remind you the 5-page presentation. The presentation is very simple. Okay, it is you can do this way or this way. Slide 1, slide 2, slide 3, slide 4, slide 5. Each slide should answer following: question, answer, question, answer. Maybe in your case, you don't have this part, key literature. Where it is. Okay? So that's why I failed. And in order to find the key literature, okay, go to Scholar. Sorry, I have the biology today. Okay. So Scholar, Google.com, and type keyword of your research. What is the keyword of your research? Keyword of your research idea, your investment idea. What's the keyword? Okay, and that's all. Okay, let me try. If you type bad model, okay, there are a lot of literature. There are a lot of literature about bad model. Okay, so you should go through some of the paper and find the content of, and basically you should do. You should provide this one, okay? And next, and if you want to use, so maybe there's also domestic literature, Korean literature. In order to check Korean literature, you go academic.naver.com. Again, you can type bad word. Okay, then okay, red. Okay, so there are not many bad Korean papers about bad model. Maybe there is some. What is the Korean translation of bad model? So you should find. Okay, you should find Korean translation of bad model and type it. Okay, and then. Okay, don't forget to your investment 투자. Okay, then okay. So there are a lot of Don't worry, you have another chance next week. Next, 현정.
My paper investigates about Kim Sung-won, and first, why I choose Kim Sung-won as my research questions. Many foreign corporate can issue so-called Kim Sung-won. It is denominated in Chinese yen and issued in Hong Kong. So according to increase in issuance of Kim Sung-won, many analysts recommend Kim Sung-won as an attractive investment instrument. Then I'm curious about why Kim Sung-won is so attractive. So first I can get a brief information about Kim Sung-won in Wall Street Journal column, and I write my paper about Kim Sung-won and why Kim Sung-won is better than other yuan-based financial instrument. So I set my hypothesis as return rate of Kim Sung-won is higher than other yuan-based instrument. First, in general, return of bond is determined by coupon interest rate, like this equation. And I refer to Professor Choi Jong-hyun's investment theory lecture notes for this equation. Yes, but when it comes to foreign bond like Kim Sung-won, we also consider foreign exchange gain or loss. So according to that structure, I put expected revaluation rate of yuan as x, and return rate of Kim Sung-won as YT, and coupon rate as CD. For the comparison, I use deposit denominated in yen, so I put interest rate of saving as CS and interest rate of saving as YS. So I have 5 data to investigate. First is expected revaluation rate of yen X, and return of Kim Sung-won YD, and coupon rate CD, interest rate CS, and return of saving YS. Since Kim Sung-won has not many academic reports, so I found his data in newspaper reports like Mail Economy and Hanguk Economy. And many websites bank that deal in Kim Sung-won and real savings. So by hypothesis in equation like this, and expected revaluation rate of yuan is 6% to 7% per year. Any global investment bank like Goldman Sachs and JP Morgan anticipate like this. And also, average coupon rate of Kim Sung-won is 0.8% and 1.5% in 1-year bond. For example, bond of Caterpillar's coupon rate is 2% per year, and McDonald's coupon rate is 3% per year. Then, interest rate of saving denominated yuan is less than 1%. For example, interest rate of deposit denominated yuan in HSBC is 0.4%, and Hana Bank is 0.05%, and SC Bank is 0.1%. The return rate of saving is 4.9% to 5.94%. It is including exchange gain or loss. And exchange rate of Kim Sung-won is 5.14% and 6.50%. I think this data clearly show that my hypothesis is valid because expected revaluation rate X is same in both sides. Difference between each side is determined by interest rate. Since Kim Sung-won's coupon rate is higher than saving interest, return rate of Kim Sung-won is higher than saving. And final conclusion, I did not consider foreign exchange market before because I did not learn about foreign exchange market. But through this paper, I realized the power of foreign exchange market. Actually, the bond itself is not that attractive because its coupon rate is really low. But by exchange gain from appreciation of yuan, dim sum bond become powerful investment instrument in these days. But it still has a limitation because I did not care about bond risk. Actually, the dim sum bond's credit rating is really high, but I did not cover risk in this paper, so it is still a limitation.
Any questions? Can you move to the literature? Key literature. Thank you. That's not enough. So I know Professor Check's lecture was fantastic and very good, but there is not cultural reference. 조선 disease is not cultural reference. So you should check whether that paper was moved. Okay. So pass. But you should strengthen that part in the content. Otherwise, you will take it back.
Do I have to submit this PPT file to you?
Yeah, upgrading.
Upgrading.
But you don't have to do the PPT. Next, G.
Okay. Before starting my presentation, I introduce the reason why I choose this topic. Actually, I'm going to United States about 2 months. In 2 months, so I just have interested in the exchange rate, $1 rate, and during finding the exchange rate, I just started real trade, not a mock trade. So, and doing that, I just found there's some relationship between two factors. I think empirically there are inverse proportion relationship in there, and after that, during surfing the internet, I just saw Dow Jones Industrial Average Index in there, and also empirically, I just found some relationship between three factors. So I have I'm just curious about that. So I just want to find it explicit relationship between there, and I want to make investment strategy in here. So let's start. My research question is: are an exchange rate, $1 rate, and KOSPI and Dow Jones Index related? If then, how could we use this relationship when we construct portfolio? So my proposition is: the more Dow Index fluctuates, the more investors in Korea can earn the money. This is my logic to the proposition. I just found some papers in the internet, and there are a lot of opinion between these relationship. There are some papers says that exchange rate and KOSPI index has has proportion. However, in my empirical experience and some other papers, says these two factors has inverse proportion. And
What is the inverse proportion?
in Korean, 반비례. I just found in the Naver dictionaries. So. Anyway, the relationship between and I just found the relationship between KOSPI and Dow Jones Index, and most of actually there are not a paper. I mean, anyway, there are papers, but there is not a paper that chart Kospi and Dow Jones Index has direct positions in Korean 정비례. My key literature is 오병철 and 박상혜's an empirical study on the current movement of Korea's stock market and foreign stock market, and to find the Kospi exchange rate and Kospi index, I just saw 강우상 and Yang Jong-won's study on the relationship between exchange rate and the stock price. So by using this theoretical background and key literature, I just make proposition again. Since those factors has a relationship, investors can make much chance to earn the money in market, especially stock market. And my data is $1 exchange rate and Kospi index and Dow Jones Industrial Average Index. I just found from 2001 January 2nd to 2011 May and 27th. The source is I just found the $1 exchange rate from KEB Korea Exchange Bank, and I just found Kospi index in Korea Exchange KRX, and I just found the Dow Jones index in Yahoo Finance site, and I just make my concept XYZ like this. X is Dow Jones index and Y is Kospi index and Z is exchange rate between $1 and $. I just use regression model in here, and my result of my data analysis is Kospi and Dow Jones index has a direct proportion relationship like this. The beta is 0.4774, and this is significant because as you can see in here, p-value it is significant, and also these significant cause express these data are significant. And next, Kospi and $1 exchange rate. It has an inverse proportion relationship in here, like this, and this also has a significant p-value, and it shows like that. So my conclusion like this. To earn the money in stock market, first in long term, when Dow Jones index shows increase, then increase weight on your stock and in portfolio and sell US dollar. And when Dow Jones index shows decrease, then you should reduce weight on stock in your portfolio and buy US dollar. And in short term, actually, I just want to make another data analysis, and I get the data. However, I couldn't make commander on R, so I need to cover up this in short term part. Anyway, when Dow Jones increased 2% or more, then my data shows the Kospi index increased in over 90%. So I just my investment strategy is buy stock on next trading day, and when Dow Jones decreased 2% or more, then sell stock on next trading day. However, there are limitations on my analysis because I just consider just three factors, and I didn't put some variables that affects in three factors and something like that. In addition, my limitation is about sorry, I forgot some my limitations. So. Okay, anyway, my presentation is done.
Any question? Yeah, I have several questions. First, suppose Dow Jones Industrial Average went up yesterday. Then when should I buy this stock?
Sorry, could you explain?
Okay, so suppose US market went up yesterday. Then when should I buy this stock? This morning, afternoon, and night, or what?
I saw the paper. The morning is more significant than afternoon.
Okay, so it means if the US stock market went up, Korean stock market goes up this morning, right? Then what
Most of the case when Dow Jones increased 2% or more.
right, those Korean stock market will go up this morning, right? Then what is the point to buy the stock once it went up?
Stop.
Do you understand what I'm saying? So US stock market will close. So when you say 2%,
Yeah.
it is 2% from morning to night, open to closing price, right?
Yes, Dow Jones is.
It is from open to closing price or yesterday's closing price. Today's closing price. How do you measure the 2%?
Actually, I just use just closing. I just use closing prices.
Right? Closing price. How about Korean data? What data do you use?
I just use also closing data is in there.
Closing data,
Yeah.
closing data. So how do you match the data?
T-1 date in US, T date in Korea. For example, if I want to face on today in Korea stock market, then I just make my reference on yesterday of US market stock
Right,
market.
so that's the problem. Okay. So basically, when you suggest current market better, it is compared between yesterday's closing price and today's closing price, right? But once US market goes up, today's opening price will go up.
Yeah.
Okay. So actually, even though investor invest in Korean stock, we cannot get a return from yesterday's closing price, today's closing price. Once we invest in opening market opening, and then we have to sell at close. So we should be return from opening to close. Right? If there is a good news in the US market, then Korean stock market will reflect that news this morning, right?
Yeah.
So when investors go to the market, they cannot make return from yesterday's closing price to today's closing price. That is not possible. Right? That's the significant problem. So you have to make sure matching the data. Okay. So once US market news is released, then after that most you have to pick a time when you enter the market, and then you have to measure the return from the moment you enter the market, and then selling time can be done, and maybe next day closing price, or maybe today's closing price, or maybe next day's closing price. Okay. And second, what is your proposition? Okay. Double as
Actually, I just want to include exchange rate in here.
So that proposal doesn't match with your data. Okay. So anyway, explain the proposition. Why do you think there is the proposition? Why do you think there is capital? Why if US now invest project? Why do you think invest in flat? Why?
Because Korea, because United States stock market affects Korea's stock market. Historically.
Yes, but that does not mean that you can make money. Right? If stock market goes up before we go into the trade, then we cannot make money.
My proposition is just
yes,
assume.
That is natural. If US stock market goes up, Korean stock market goes up as well, but that does not mean that we can actually make money. Right? Because US stock market goes up, and the stock market, Korean stock market goes up before anyone starts trading. Before as soon as market opens, just price jumps up. Then whenever we are invest, we can have to buy stock at higher price. So correlation does not mean that we can actually make money. Okay, so basically you have to provide logic, not correlation, but about profit trading. Okay. The correlation is not with correlation. Why that? So do we have this correlation? It seems you don't, so you fail. Okay, so please address the issue I just mentioned and continue this on the next.
Hi, my investment is using distress risk for tactical as a location. So my research question will be is how can distress risk be used for tactical as a location in Korea? So my background literature is research on distress risk, which is written by Professor Campbell and Nell. And this paper explores the determinants of corporate failure and the pricing of financially distressed stocks whose failure probability is high. And they use logistic regression to estimate probability of going to bankruptcy. And the four accounting and four market variables are conserved. And the stocks with high distress probability estimation have a low return and high volatility and high market and small cap beta. And also this paper applies the distress probabilities to TA, tactical asset allocation. So, question, how did you select cases? In Korean stock market, there are still many individual investors who speculatively invest in distressed stocks for the purpose of taking premium for their series. So their simple conjecture is high risk, high return. For this reason, Korea stock market is one of our case to see whether the market anomaly, which is explained by Campbell et al., exists, and to exploit the fact at the TA signal. So I used Google, Wikipedia, and I also used KRX page, and I also received kind of refined data from some asset management. So, according to the predicted distress probabilities, I constructed some portfolios. So, investment strategies are set as follows. First, stocks are listed from lowest to highest according to their predicted distress probabilities. And second, long portfolios are constructed with stocks whose ranks are from 1 to 50, 51 to 100. And for example, stock 1 means that it has the lowest distress risk, and stock 100 means that it has the 100th lowest distress risk among stocks during the predicted ones. So first table shows the statistical results of each portfolio. As you can see, as the distress risk increases, except the least distressed stocks, as the distress risk increases, their annual return is decreased and sigma is increased. So with these findings, I made some investment strategies. So according to the research, I thought 200 stocks with the lowest distress risk and construct long portfolio with those stocks. And I compute mean and median of historical monthly average of predicted distress probabilities and set average of the mean and the median as the threshold value. And lastly, if the current average of predicted distress probabilities is higher than the threshold value, and I short the portfolio, I name the portfolio L200, and otherwise I hold the portfolio. So I simply, if the predicted distress risk is looked like this, and the threshold values use the historical data. So if assume threshold value is like this, when the distress risk is smaller than threshold value, I hold the portfolio, and if the predicted distress risk is higher than threshold value, I short the portfolio I have. So the second table shows the result of my investment strategies, and Kospi 200 is benchmark. So as you can see, these three strategies shows very outperform the benchmark. So graphically, this one is benchmark, and the red dashed line is L200 portfolio, and the black line is just use the threshold value, and the red line is used to the L portfolio and threshold value together. So my hypothesis is the more distress risk, the less return and the more volatility. I found the same result in Korea stock market as Campbell et al. Find in US stock market. As the distress risk increases, the return decreases and volatility increases, except the least distressed stocks. So these proportions are valid. The more overall distress risk, the worse overall market condition. Using the average of predicted distress probability, it is possible to predict overall market condition and avoid financial disasters such as global financial crisis in 2008. So conclusion, one disadvantage of the investment strategies. The strategies have too long quiescent period, which means during this period actually means I didn't do nothing. I do nothing. So it should be solved. And so this disadvantage makes the investment strategy impractical. So unexpected short-term events cannot be captured by this distress risk because this model uses, it's kind of fundamental model. So it cannot take the kind of sentiments of the market. And advantage of the investment strategies. Distress probabilities can be used for portfolio constructions, and TA signals from distress risk prove to be effective in predicting overall market economic condition. And more performance enhancement is available when used with other investment strategy. So I'm planning to use these strategies as supplementary TA signals for sentiment strategy. So what I learned is distress risk also can be used as a signal for TAA as well as CDS rating, and so market anomaly of distress stocks. That's it. This is the end of my presentation. Any questions?
Just have a question. If you sell your portfolios in there when the risk is more higher than gas in there, is there any alternatives? I mean, rather than holding in cash, is there any alternatives to make more profit?
So what I think is two kind of things. One is using sentiment, already I showed, and one is using Kospi 200 future, because it goes reversely when the market. So I'm still investigating whether it's good or not. Any questions?
Any other questions? Okay, pass. Okay, well, simultaneous equation model. Why cursor is blinking? By the way, we should congratulate Byung-chul. He got an official offer from Samsung Asset Management as an intern. That is actually very tough. So actually he defeated competitor, MBA, PhD competitor from KAIST. Okay. And as well as strong competitor from Seoul National University. He defeated them all. Okay. And got the offer from Quantity. So I think that we really should congratulate. So good job. Okay. But at the end of the internship, you should do a very good presentation in order to get a final. Okay, about simultaneous execution model. Example number 2. Okay. Suppose the first one is demand curve. Second one is supply curve. Okay. And in view, we can only observe your market equilibrium when demand equals supply. First one is demand function. Okay. Second one is a supply function. Therefore, I think beta should be negative and delta should be positive, right? Because demand curve is downward sloping and supply curve is upward sloping. Okay. So if we have a model like this, then the question is how we can estimate those parameters alpha, beta, gamma, delta. So which variables are exogenous and endogenous? What are the structural equations? So this is structural equation. And then in real life, of course, we never observe demand or supply. Okay. So we learn demand curve and supply curve in the economics class, but in practice, we cannot observe them directly because we can observe where supply and demand meet. Okay? So we observe only the equilibrium price and quantity. So given the data of equilibrium price and quantity, basically we need some technique to extract, okay, the demand and supply. So consider the price and quantity combination in figure 1. Okay, so this is typical data. Okay, then only looking at this type of data. So x-axis is price, y-axis is quantity. So it is typical data, and even with this kind of pattern, it is not possible to. Okay, it is not possible to tell whether it is supply curve or demand curve or what. Okay? It is just equilibrium point, quantum equilibrium point. It doesn't tell much about supply or demand curve. We need some technique to extract those two curves out of this pattern. So what do the demand and supply curve look like? Okay, we all know demand curve should be downward sloping and supply curve will be upward sloping. And we could fit an OLS trend line to do the data in figure 2. So if we do the OLS, then what line something like this. Okay, but it doesn't have anything about supply and demand curve. We could fit an OLS trend line to do the data and in figure 2. But such a line is neither supply nor demand. Okay. Now we can write the structural equation. So it is a structural equation. So we can rewrite the structural equation such that, let's say QD QS equal to Q, some equilibrium Q, and then we plug those Q into the here and here. Okay. So basically we can rewrite this equation into this form. So the question is, if we write down structural equation, demand supply, into this form, in equilibrium, then, and then if we run Q as a function of PT, okay, so QT use QT as a dependent variable and PT as an independent variable, and if we run regression, then what are we getting? Okay. The reduced form for this model would be, okay. Since Q, we have the same Q, this equation, so we can make this one and this one equal. So we can write down this formula like this, okay, like this, and then we can solve for PT. Okay, we can solve for PT, so PT would be look like this. Okay, eventually the similar reduced for the equation of QT, right? So once we get a PT, so it is equilibrium price. And once we plug this equilibrium price into the P here, then we can get the equilibrium quantity. Anyway, given consistent estimate of the reduced form parameters from OLS, so basically we can estimate P and Q separately with those parameters. There is no way to solve for the structural parameters. Right? The reason is that, okay, we can observe P and Q. Okay, so basically we have only two equations, right? Equation about price and equation about quantity. We have two equations, but how many parameters do we have? We have parameter 1, 2, we have 4 parameters, right? So we have 4 parameters and we have only 2 equations. Therefore, basically we cannot solve. Okay? We cannot solve this equation, so we cannot identify all the parameters. We start from this model, this structural model, and then we make demand and supply equal, which is we set it Q, and plug this same value to this equation, so we have this one. And in addition to this equation, now we have additional parameter like theta y, okay, where y is exogenous. So y, we can, in this case, y is kind of income. Income of a person. Okay? So first one is, of course, we impose equilibrium quantity to this first demand curve. So therefore, what should be the sign of the theta? Any idea? It should be positive or negative. Here, what do you think it should be? Is theta should be positive or negative? So y is equal, this is your quantity of demand, isn't it? What should be the relation between your income and the quantity? Plus, yeah. So if you receive 2 times of scholarship, okay, then you will do more shopping. So it should be positive. So why is income exogenous here while it was endogenous in the last model? Okay. In the last class we learned GDP cases, right? So in that case, income is endogenously determined. Income is function of also individual consumption and investment and everything. But this is like just one market, and you can in this small one market, you can get the income of a percentage exogenous to the model. So we can regard income as exogenous to the model. Okay. And now suppose you can write down reduced form equation. Okay. Okay. So we can solve the problem. Okay, we can solve the equation. So we can set this one and this one equal. Okay, then we can solve for P and Q. Okay, we have two equations. So we can regard this equation 1 and equation 2. We have two parameters to estimate Q quantity and price. If we solve this one, then we have this one. Right? And this is reduced form equation. Okay, so price is now function of some virtual parameter. Okay, and Q is also function of virtual parameters and income. And then we can simplify this term as pi p0, second term as pi p1, and for second one we can regard this as pi q0 and second one is pi q1. Okay? So in this case, okay, so if we look at the parameters carefully, and if we compute ratio, okay, if we compute the ratio of this one and this one, basically this ratio between this one and this one. Okay, so if we calculate the ratio of this one and that one, basically we can get the delta. Okay, right? So this is very important. So suppose we have income data and we have equilibrium P and Q, and we can run the regression for this, and we can run the regression for this. Once we do the regression, and we can identify this, right? And once we identify this, and this, and if we calculate the ratio between the two, then it becomes a delta. Okay? Delta is actually what? It's the slope of the supply function, supply curve. Right? So by having exogenous variable, income variable in demand, basically we can now identify this parameter. Do you get it? Thus, given the consistent ILS estimator, indirect risk square measure, which is reduced form of this parameter, of this one and this one, we can get a consistent estimator of the delta. Okay? Basically, OLS parameters are estimate of OLS coefficients are all consistent. No ratio of the consistent parameter. So the final value should be consistent value for the supply curve. Consistent estimate for the coefficient of the supply curve. Okay? Draw new picture with the shifting menu. So, okay, the intuition is very simple. Okay. Intuition is okay. So this is supply curve and demand curve. Okay, so match the axis. Okay, this is P. Okay, usual demand curve. So x-axis is P, y-axis is Q. Okay, so in supply and demand curve, and usually what we can observe is like this. Okay, something like this. So we observe a bunch of data. Okay, bunch of data like this, which happens because of equilibrium. But now in our new model, we have a shock in the supply demand function, right? So we have a shock to the demand function, which means that now as income, okay, in this model, as income fluctuates, which means that our demand will fluctuate as well, right? So when income goes up, our demand function looks like this. Okay. When income goes down, our demand curve looks like this. So whenever demand curve moves, we have a new data point. Okay. Of course, supply curve will move slightly, but because of the income, okay, mostly demand curve will move, right? So since demand curve moves and we have a new point, because of shock in the demand curve, it keeps track of basically supply curve. So basically by linking those 3 points, we can recover supply curve. So which is important. We need exogenous shock to the demand curve in order to identify slope of the supply curve. So to inverse the argument, we will need a shock in the supply curve to identify the slope of the demand curve, right? Any question? This is actually very, very important. Okay, now consider the model. Okay, so we have still income shock. Okay, income shock in the demand function. Now maybe there is shock to supply curve as well. Okay, so these are exogenous variable affecting supply, such as maybe a measure of weather, right? So weather is completely exogenous variable, right? It is determined outside of the model. Right? Weather is not determined in the market. Weather is determined by the natural phenomenon. So, and we know weather may be affect. Weather may affect supply, right? If we have a tsunami, there is a disaster in the U.S. supply, Japanese supply chain, right? Something like that. So maybe there is shock. So if we have a shock in the supply curve, then what's going to happen? Maybe we can use this shock, this information, and we can identify slope of the demand curve as well. So in general, okay. So basically, we want to identify full supply curve and full demand curve. Okay? And there are 3 issues we will deal with in the rest of this section. First is identification. Basically, what kind of information we need to identify those parameters. Okay? And second is estimation. Once we can identify those parameters, then maybe we need a strategy to estimate those parameters. Even if we cannot identify parameters, then whatever estimated technology we have, we never able to estimate full parameters, right? So first we have to make it sure that we can identify all the parameters, then we can use our technique to estimate those parameters. And then third, once we estimate parameters, we can investigate what is the properties of the estimate. Yeah, section 3, general formulation of model. So we can basically write this type of equation in the matrix form. Okay, so there's maybe pre-multiplying matrix B and YT and C, XT and UT. So YT, so there are basically n number of basically dependent variable, okay, and m number of independent variable. And those dependent variables have a relationship with each other, and independent variables relationship with each other. So B is n by n matrix, and C is n by m matrix. Of course, it is error, so it is n by 1 matrix. Actually, why don't you take a break? Let's take a 15-minute break. Okay, so suppose we have T observation. So this is one observation. So we have, so this is n by 1. Okay, so it can be because this is one equation. So we have T set of this kind of equation. So we have in total n 곱하기 T n multiplied by T. Right? We stack the data or observation together. Then basically this is T observation. So B is n by n and Y is n by T matrix. We make it this way. We keep attention to the data in the column. Okay? And then C is n by m matrix, X prime is n by T matrix, and U is n by T matrix. Okay? So in this case, okay, of course, important assumption is that B is non-singular. Okay? B should be non-singular, and all together elements of B are 1. Right? And it is natural assumption. If they are not 1, we can simply divide each side with some constant so that we can make all diagonal terms equal to 1. And the errors are important. So the errors are we regard this or this to be like this. So this omega is some sort of positive by definition. So you data structure of this. And let's say x prime is exogenous. Okay. So this basically y, because y, they are set of endogenous variables, like price and quantity, dependent supply function, and x are exogenous variables, like income and then weather, something like that. So it means we have n exogenous variables, and we have n endogenous variables. So x prime is exogenous. And a priori restriction on VC. Okay, a priori restriction on VC may be from theory such that, yeah. So, I mean, if they are supply and demand function, right, they should be natural assumption that the supply flow of supply function should be positive, the slope of the demand function should be negative, something like that. Okay, so there should be some theoretical assumption about the parameters on VH. Now, okay, given this setting, what we can multiply inverse magnitude of V each side, and basically we can express all endogenous variables as function of x, like this. Here, anything fun? Anything fun? Text messages. Okay. And we can express like this. Okay. So basically we express all endogenous variables, function of exogenous variable, and then we can write B inverse C as A and B inverse U as V. Now we can observe or more precisely consistent estimate A, right? We can naturally estimate A by running regression y on x. Okay, so x are exogenous variables, so we can run the regression and we can run the recover A. Right? So basically all parameters in A are, we can identify all parameters in A. But the question is, okay, but A is less interesting parameters. So parameters we are interested in is actually this structural parameter B and C. Right? Okay. A is simply V inverse C. So even though we know A, it does not mean that we know B and C. Right? So we need some structure, some restriction to recover B and C from A. Right? So we can observe or precisely consistently estimate A, okay, by running regression, for example, but we want to know VC. Okay. In B, there are n square minus n unknowns. Why we have n square minus n unknown in B? Why do we have n square minus n unknown? Right, exactly. We have n by n parameters in B, but we know all diagonals are all 1. Therefore, we have n square minus n my number of parameters to estimate. Right? And C, there is no restriction. So in C, we have n by m unknowns. Okay, and in A, okay, in A we have n minus m unknowns. Right, so suppose we know A, then we have n 곱하기 n multiplied by m and m equations, but unknown number of parameters is n square minus n plus mn, right? Which is greater than this one, right? So we cannot identify all the parameters in B and C. We need more equations. Therefore, we need at least n square minus n more equations, right? We have more equations, so which means we need n square minus n number of restriction, okay? More equations, okay? Because we have this number of unknowns, so we need this number of equations. But we have only this number of equations. So we need this number of equations more, which can be the restriction of B and C. Okay? So I mean at least this number of parameters, and if we have more restriction than that, basically there is no unique solution for that one. But anyway, it's fine. Anyway, the possible restriction, one possible restrictions are first, Bij, Cij equal 0. Okay, they are called zero restriction, and they are the most common types of the restriction. So we simply say those parameters are 0. Okay? Or some of the parameters are 0. Okay? So if we have enough number of restrictions such that the parameter in those restrictions, if we have n square minus n number of zeros, we can impose it, then basically we can identify all the parameters. This is the easiest one. Second one is maybe we can give n square more than n square minus n distribution as this some sort of linear equation. So maybe a variance or non-linear restriction. So then we can assign any crazy restriction. Okay, this is linear, right? Okay, maybe there will be non-linear restriction as well. Okay, so this kind of restriction can lead to many different things happening. Okay, no structural parameters are identified with no restriction based on A. Second, some but not all structural parameters are identified with no restrictions placed on A, and some but not all structural parameters are identified with restriction placed on A, and all structural parameters are identified with restriction placed on A, or all structural parameters are identified with no restriction on A. The fifth possibility is called just identified. And the third and fourth are called order identified, and we can also talk about identified structural equations. So this sounds strange, but we will discuss those in detail. Okay. So anyway, first, maybe we want to find the necessary and sufficient condition for identifying all the structural parameters. So let's define P as a collection of V and C, right? So therefore, this is structural parameter. So let's collect B and C together and define the new matrix as P. Okay. P, and then we can write J's restriction on I's equation. Okay, J's restriction on I's equation as a form of something like this. And assuming that there are Ri restrictions on the I's equation, and let's say restriction looks like this. Okay, so basically, we have to rewrite the structural equation. So basically we can put this together, and then y, x. Okay. So the better one is put y and x this way. Actually, we need minus x over here, and the p is between b and c. Okay, it's this way or that way. Yeah, anyway, yeah, actually. Okay. It looks like this. So basically, when you impose restriction is basically relationship between the parameters in this P, right? And suppose there is a linear restriction, okay? So to generate combination of these parameters in P, okay, we can write down L restriction in this form, right? So we can call this is J's restriction on I's equation. So maybe we have Ri number of restrictions, so it is number of restrictions. So basically we can write down all restrictions this way to give Ri number of restrictions. Okay. So for example, okay, then we can write all the restrictions on the I's equation as this formula. So quick example, okay. So let's say this is our equation. So in the right hand side, we have only arrow term and we move all the variables to the left hand side. Okay. Then P looks like this, and this X is x, y1, y2, and xy combination of y and x. And so P looks like this. And then the restriction we place on the structure R. Okay, let's impose restriction such that okay, P R gamma 1 is 0. So there is gamma 1 is no gamma 1 right? And so gamma 1 there is no gamma 1. So gamma 1 1 and gamma 1 is 0. So here this restriction should be 0 to match this one. We have these two. So if we rewrite this matrix, if we use matrix notation, then we have okay. And then beta 2 1 is actually beta 2 1 also it should be also 0, right? But there is in the second equation there is no parameter for this one. There is no parameter for this one. So actually this one should be 0. So we need basically we have three restrictions. This one 0, this one is 0. Okay. To express that restriction in the matrix formula, we can define okay, big P1 and big P2. And 0, 0, 1, 0, and 0, 0, 0, 1, and this 1, 0, 0. Okay. So if we multiply this to this matrix, and then we have 0, 0. Right? And if we multiply this one, then this term will be 0, and I multiply this one, then this one should be 0. And then about second one, okay, okay. So I multiply, we have to multiply this into this equation. Right? Then we have restriction about this equation. In order to generate restriction about this one, okay, we need this basically restriction on the second equation, right? Restriction on the second equation. So we multiply this matrix into the second one. Then if we multiply it, usually it's beta 2 1 equals 0. Right? So basically P1 is first row of the P, and then multiplying this one. By saying this one is 0, then we have restriction for this one and this one. Okay, and for P2 0, then we have restriction about beta 2 1. Okay, if we continue with the general case, okay, and the I's equation, okay, I's equation is identified, okay, if and only if P multiplied by theta I becomes the rank of that one becomes if that becomes n minus 1, then it is easy to show. It is not that easy, but we can show that that is just identified. Okay. Maybe the necessary condition, one that is more easier to check is we can actually count how many restrictions we have. Okay. Once we count that and we compare that with n minus 1, so n is again number of endogenous variables. Right? So we can count the restriction, and then we count number of endogenous variables and minus 1, and then compare that we can have a necessary condition. and we call this condition as a rank condition. Okay, we call the second one as order. We call the second necessary condition as order condition. So again, rank condition is this, and it is if and only, and it is necessary condition. Okay. So suppose we have a structural equation, and suppose indeed the number of restriction is greater than number of endogenous variable -1, then what is going to be our next step? Does it mean that we have all the restriction we need? Does it mean that we can identify all the parameters? Here, how do we do? So suppose our structural model pass this order test, order condition, and do we have to check rank condition or not? What do you? So if a model it is if and only, right? It is sufficient. So if a model satisfies a rank condition, then we are done. Okay, we are done, and we can identify all the parameters. But if our model satisfies the other condition, then since it is a necessary condition, so it's only necessary condition, right? So which means that still they may not be identified. So if our model passes this order condition, then next we have to check rank condition. Right? But since it is necessary condition, so if our model fails this order condition, then actually we don't have to check anything else because it is necessary condition. So if we fail, it fails everything. We cannot identify all the parameters. So a good way to check identification for the ith equation is therefore to first check the order condition, and then if satisfied, check the rank condition. Okay. Now, example to continue the example, basically P multiplied by first restriction, set restriction, if we multiply them, then we have basically gamma 11, gamma 12, gamma 12. Right? Basically, we recover this part. And the restrictions are true, or is it true, then this should be 0, 0, 0, gamma 2, and gamma 2, 2. Right? Which is, though we can calculate the rank of this matrix, and this is 0, so the rank is 1, unless both of them are 0. So unless both of them are 0, the rank is 1. Therefore, the first equation, we can identify the first equation. Okay, if they gamma 21 and gamma 22 are 0, what does that mean? Okay, what does this mean? Jay, can you explain? If these two are 0, okay, in our equation, so it means that this and this are 0. Okay, then what's gonna happen?
The rank is 0, so
okay, so we can again go to our supply and demand curve. So if we don't have this part, so both of them are 0, we don't have this part. If we don't have this part, basically we cannot identify this one, right? So at least one of these should survive. Okay, so this moves, then we can identify this one. Okay, so they should be 0. Okay, thus identify that unless both of them are 0. Okay, we need at least one shock, either this one or this one, then we can identify this equation. Okay, about second equation, okay, we check this one. Okay, so it is this is 1, 1, okay, and multiplied by this second restriction, then it is 1 beta 2. Okay, so rank of this one is simply 1. Okay, so the second equation is always identified. Okay, so this equation is always identified. It's natural, right? Intuitively, this one should be always identified because this is the function of only exogenous variable. So we can basically move this one and run the regression of this one only. We can always identify all the parameters. Right? So it is very intuitive. So anyway, the second equation is always identified. Intuitively, second equation is always identified because we don't have this part in the second equation. Okay, any question? Now, our second strategy of instrumental variable, it is part of your homework. Okay, to remind you the homework until next week. Okay, your homework due next week is, okay, do again estimate area run about Cochrane of procedure and construct the Wilson statistic to test significant of law. Okay, this is homework of 2 weeks ago. Okay, but since you didn't do it, you did it last week wrong, and you didn't do it this week, so please do it again until next week. And then another homework is conduct instrument variable regression with regular value and 2 second stage risk equation. So basically you have to use the data you collected, and you have to do instrumental variable regression with regular variable and 2 stage risk square estimation. Okay? I'm going to explain it now. First, consider the model y is x beta plus q gamma. Okay, and if we can find k regressors on z, so basically it's t, so t number of observation, and we have k number of regressors on x, and such that p lim probable limit of this one is invariable, and probability limit of z part, and this is invariable. Okay, and they are orthogonal each other. Then we call these regressors are instrument, and we can use them to construct instrument variable estimator. Okay. So I mean the critical part of this equation is that these x's are kind of endogenous variable. In order to run the regression, both x and q shouldn't be correlated with this epsilon, right? So in this case, q is orthogonal to epsilon, but x is not orthogonal to this one, right? So basically our regression breakdown, as I explained before. But in order to estimate all the parameters gamma and beta, basically we need another set of regression called z. And if z satisfies these 3 equations, so z is correlated with x in the probability limit, and z prime z is invariable, and if that instrument z, another variable, is not correlated with the epsilon, then what can we do is, instead of using x, we can construct z star gq, and as a matrix of all exogenous variable, and then let's call x prime as xq, and then we can rewrite this equation in this way, right? We collect x and q together and define an x star. Okay. Now b prime should be beta prime, beta star is beta and gamma, right? Now in this case, okay, so we basically transform this equation, okay, into this way, and then the next step is multiply our instrument, which is collection of z and q, in front of this and this. Okay, then we have this one. Okay. And then if can drop the last term and solve for, okay, let's ignore this one for the time being. And then if we solve for this beta prime, then we have equation something like this. Okay. And let's investigate the property of this one. And then instead of y, we can put, okay, y looks like this, so we can put y inside of this y. So this basically estimate it looks like this, and then we multiply this part, and this cancels out, and we have only true parameter, and we have error term like this. Okay. And then let's compute the probability limit such that if we compute the probability limit is constant, we have this term, and then we can consider only probability limit of the second term. And then let's divide this one as t and t. Okay, then this cancels out, so they are the same. So probability of this part, by our assumption, this exists, right? And the probability limit of this term is 0, right? So this kind of regression, okay, once we solve beta like this way, this is consistent estimator for true beta. Okay. So again, okay, our idea is when we have correlated regressor independent variable like x, what we can do is we find another variable like z and construct this one and regression to the regression like this way. in your homework, okay, you have power frequency factor model, this type of regression, right? So as an instrument, okay, you to do the instrument regression, okay, this type of regression, you need to constantly see, right? So for Z, what you can do is, okay, X star is the same to like this, and Z is one of the lagged variable of one of your data. So if you regress stop return of power from these three factors, then you can rank one of them, okay? So you can, if you use daily data, you can send one of the data by 1 day back, okay, and use that as a regressor. Okay, the intuition is that maybe one of your power factors is maybe correlated with the error, today's error, so it's concurrent regression, but maybe yesterday's value of power factor are maybe not related with today's issue. Anyway, this is the intuition. So please choose one of the. Actually, you can. Please construct this type of instrument value by ranking your data. Okay. So this is when you do the regression instrument variable regression like this. Okay. So X is still same to the collection of power frequency factor, and Z include one of the lagged variable and other things. And just calculate this, and you will have instrument there. You parameter estimate from the instrument variable regression. Okay. And that, if you do the regression that way, that is actually consistent estimate. Okay, it is consistent, and next we can investigate asymptotic distribution of this instrument variable relation. So we have this relation. So beta hat minus beta. Okay, this part can be expressed in this way by the definition of beta, and we can multiply square root t each side. Okay, then this cancels out. So we have this part, right? And we know in probability limit this exists, and this will need goes to 0. But now we are interested in variance metric. So the variance covariance matrix of this one, so which is we have this one, so we have to transpose it and multiply each side inside. So variance covariance matrix of this one looks like this. Okay. And about this term, okay, root t, so we have t. Yeah. And probability limit can go inside of the multiplication, so we can send probability limit into those three pieces. So probably this side, this side, this side. And by the assumption, okay, by the assumption, this epsilon prime is sigma square and identity matrix. So this one, second we have this one. And of course we have identity matrix, but multiplying identity matrix is there. So then this cancels out. So along is the central limit theorem. Therefore, what we can say is that the probability limit will converge to this, and we have this part. Okay? So basically, since we can construct various covariance matrix of our beta, okay, which means that we can calculate, we can do the hypothesis testing, right? Because we have this tree. So in your homework, okay, okay, instrument with lagged variable. Okay, I think that's enough. Okay, you don't have to do hypothesis testing, but if you want to do hypothesis testing about the critical variable, you have to use this. Then now, of course, the question is, where should you find the instrument? We assume the existence of some z, right? Z number of instruments. So some instrument may be partly excluded with some exogenous variable or lagged or leading regressor. There is homework. Okay. So we do the rag or some regressor, then we can use that as an instrument. Yes, or maybe exclude the exogenous variable from implicit equation or out of thin L valid instrument or like somewhere else. And two-stage risk curve or first-stage prediction. We're gonna deal with this one now. So two-stage risk curve. This is also part of the homework. So two-stage risk curve is a special case of instrument variable prediction we just learned. And continuing with our structural model. Okay, so this is same as before. And again, let's consider a case where we have instruments of V, P, Y, M matrix. And the number of instruments which is M is supposedly greater than K. Okay? So now, okay, our number of instruments is greater than number of K. So therefore we have more instruments than the number of endogenous variables. So basically we cannot simply run endogenous and instrument variable relation as before. That is not possible. So if you instrument and the number of instruments is greater than the number of endogenous variables. So when M is greater than K, okay, then we would like to be able to use all of the instruments if then still satisfy the condition that it is vulnerable. Okay. So of course one obvious idea is out of this M number of instruments, we can discard some of them and we can choose only K number of instruments and we do the same regression as before. Right? That's the one idea. But suppose we want to use all the information, okay? All M number of instruments, then what should we do? Okay? The idea is works like this. Okay. Again, we construct the Z matrix. Okay. Again, we have a Z instrument. So first idea is, first we run regression. Actually, we do the projection. Okay. So Z prime Z inverse Z is, we call this a projection matrix. Right? Do you remember that? So it's a projection matrix. So what we first do is we project this X on the surface of Z. Okay. So we do the projection of the X on the plane of the Z, and then we generate Xi hat for each endogenous regressor, and we define this one like this. And second, okay, and so basically X looks like this, and note that, okay, Q so basically, even though we do the projection on Q, then we still have the same Q, right? Because Z is Z. This is Z star matrix include Z and Q, right? So we basically do the projection of the Q on the surface of the Q, part of Q. Therefore, it should be the same value. So in this case, we do the projection on the surface. There is surface does not include N. So they are different, but in this case, we do the projection on the surface that is already included. So I'm talking about intuitively. Therefore, it should be this Q hat should be equal to Q. Okay. So basically, this X hat Q should be equal to X and Q hat equal to Q. Then as a next step, we can use this X hat, X prime hat, as an instrument, and you can simply run the regression like this. And the head looks like that. Okay. And it should be a valid instrument. Okay. I don't know why I have an error. So again, two-stage regression is sometimes simpler. Okay. First, okay, in the original equation, we have a problem about this part, right? So what we can do is, okay, we collect this one together, and we simply project this data matrix on the surface of the Z matrix, okay? And once we do the regression, and then we collect those regressed ones and construct this X hat again, and instead of this one, this X, we use X hat as an instrument like this. So to compare this one with the previous one, okay. So z is our instrument variable, right? And we solve this. But instead of z, now we use x prime, x hat. So we can regard x hat as a like instrument. Basically, it's instrument, right? We regress x on the surface of the instrument space, and we use that projected values as a new instrument. So basically, we don't lose much information. Okay. So in that case, so by this process, we don't have to discard any of the instruments. So basically, we can regard this x hat. Okay, this part as a new instrument. So PLM is invulnerable to check whether this is valid instrument. So instrument should be correlated with our endogenous value, but the instrument should be orthogonal to the other error term. Right? So to check the instrument, first this one is invertible, that's easy to see. So x star prime x star and looks like this. Okay. So z prime x. So instead of z, we have x hat star. So if we can calculate this one, then we have this, and we have this. And which should be invulnerable if x prime z divided by t is invulnerable. Okay. And if z is a valid instrument, that should be invulnerable. So therefore, as far as z is instrument, x hat star is also instrument. And second, this z prime z should be invulnerable. So we have x hat star prime x hat star, so which looks like this, and we can solve. We have this one, and then to calculate this piece by piece, we have this one, okay? And this one cancels. Okay, and this one is cancels. So we have only that one. And x prime, x hat prime q looks like that. Okay, and as you know, even though we do the projection of the q on the space of the z, the z includes already information of the q, so it should be q. So therefore, by using this property, we can solve this one. Okay. So x hat star prime x hat should be look like that, which is same to equation 6. Okay, so which should be invulnerable. And finally, the most important, our instrument should be orthogonal. Okay. In problem, we should be uncorrelated. Okay. So basically, we can rewrite this like this. And we already know they are exogenous, so this should become 0. And about this term, okay, about this term, as far as v star is exogenous, this term should go to 0. Right? So also go to 0. It satisfies that probably we will be fine. That's what. And next, what happens if we put the two-stage regression together? So y looks like this, okay, and we know y prime, okay, y has top prime, y has top will be look like projection of x on this state. So basically, we can express this part as this one, okay, and instead of this one, we can have this one. Okay. So basically, it's projection matrix, so we can rewrite this as PZ. So it looks like this. But since P is a projection matrix and projection matrix is orthogonal projection matrix, and it's identical matrix. So actually, PZ, if we multiply P 2 times, it should be the same P, right? We multiply this and together cancels out. So even though we multiply P projection matrix 2 times, we have the same projection matrix. So instead of P, we can write down P together. Right? And then we have very interesting pattern. Okay. We have projection. We have x hat about this one and this one as well. Right? So in that sense, the interesting part is we can use we regard this one as instrument value, but actually instead of x, we can also use this x hat. Okay, x hat, right? So like this. So it means that actually we can regard this x as a new independent variable. Right? So instead of x and regard this like this, what we can do is from the beginning we put x hat over here, and we can simply run OLS regression. Okay, then OLS regression coefficient for beta should be like this. Right? That is OLS regression. So basically, it is easier than instruction regression. Right? You can simply transform data, simply project your data onto space of your instrument, and then simply regard that as your new data. And you can run regression. You can use like R kind of regression. So that is much easier. And both methods are identical. Okay, equivalent. Anyway, please try this instrument variable regression. And of course, you simply use pharmacometric factors, and then for this two-stage regression, to make this two-stage regression interesting, maybe you will need another factor. For another factor, maybe it can be instrument. For another factor, I may suggest some kind of industry report. Right? So if you use Google data, maybe you can get the data about the IT sector and use that as another set of instrument, and you can run the regression. Okay. And you will have more instruments, then more instruments, and the exogenous variable and number of independent variables. Okay. And you can interacting two-stage least squares. Two-stage least squares. Okay. Now next, what is the statistical property of the two-stage least squares? It is very similar to the instrument variable. Okay. So again, parallel looks like this, and P is projection matrix on the space of Z. Okay, looks like this. Okay. So instead of the Y, okay, we put our original equation, which is x prime beta prime plus f. Then this whole thing, we look at this, and they cancel out to give this over here, and we have this part. The probability limit of the beta, okay, probability limit of beta will be probability of this part and probability of this part, and then you can expand this projection matrix part, and we multiply t everywhere. We multiply and divide the t everywhere, okay? Then basically this, because of this inverse part, these three t's and these three t's will cancel out. And then once we enter this, then we can set probability inside, right? Okay, then this will become a stable metric, because this all exists, and this exists, and this exists, but this will go to 0. This goes to 0. Therefore, two-stage least square estimator is still consistent estimator. Okay. And why can we use expected value? Okay, we show consistent use by probability limit P limit, but the question is maybe we can put expectation sign over here. Okay. What's going to happen if we put expectation sign over here? Okay, if we set expectation sign over here, then it's constant, so expectation of this one is simply this one. And expectation of this one, we have expectation of this whole part. So if expected value of this one is 0, then we will have an unbiased estimate. Right? If our expectation of our estimate is the same to the true parameter, then we say it is unbiased estimate. The expectation of this part is 0, then we can say our two-stage least square parameter is basically unbiased estimator. But do you think the expectation of this part will be 0? How do you think? Hyunjung, how do you think? What's going to happen to this one when you take expectation. I beg your pardon? Why? You don't know why? Okay. Actually, there is not zero. Why? That is not zero because again x include endogenous variable, right? So z is just a parameter. Right? This is some parameter. So even though we multiply some parameter to this endogenous variable, it is still remains the endogenous variable. So because x and original x and epsilon are correlated with each other, therefore we cannot say expectation of this part will be zero. There will be still correlation between the epsilon and this one. But even if this part is in space not zero, in probability limit, if we have a large number of data, this part will go to zero. So that's the interesting. So again, our two-stage risk square estimator is biased estimator. So it is not unbiased, it is biased. But if we have a large number of data, it converges to true value. Okay, now next we can investigate probability distribution. So again, we use the usual technique. Various covariance matrix of V. Of course, we have multiplied square root of T, then we have this part. We use this property. So basically, we are using this equation, not this equation. Basically, we are using this equation. So we put this one over here, multiply square root of the T. And then about various covariance matrix, we multiply this and this together. And then about probability limit, okay, we use usual technique. Okay, before that, we expand projection matrix V and like this. And then next, we divide everything by T. Okay, so looks like this. And then once we write down like this, then we can send this probability limit inside of the equation. Inside the equation, then like this and like this, okay? Like this. And about this part, epsilon prime is with sigma square I, okay? So we can put sigma square in front. So we have this whole bunch of equation. And fortunately, a lot of them cancels out this entire thing, and this thing and this thing cancels out, so we have only this part. Okay, only this part. So basically, variance covariance matrix of our two-stage risk curve becomes improbable limit should be like this. So along with our central limit theorem, which means that square root of T and beta prime star minus beta is to normal with mean zero and some various covariance matrix, and various covariance matrix will look like this. Okay. Let's summarize the relation between IV, instrument variable integration, and two-stage risk square. First, two-stage risk square is a special case of IV. Why? Punctual why? Why can the two SLS is of IV. Because in the two-stage regression, basically we regress our endogenous variable on the instrument case, including instrument variable, right? And we regard that as an instrument. Okay. So first we can regard first-stage regression as a generation of instrument. Okay. So therefore, two-stage is a special case of IV. And two-stage, two SLS provide an optimal way to use instruments when there are more than necessary. And third, when the number of instrument is now, when the number of instrument is equal to number of exogenous regression, we say that the equation is just identified. So two-stage regression, two essays will look like this, right? Look like this. But now C include exactly the same number of instruments, right? So basically, okay, we can. This one is all square matrix. Square matrix. So we inverse it, so this one will go inside. Now everything is square matrix. So you change, right? Change this, so inverse matrix is 5 and then G. And now what we like to you can write this and they cancel out. But they cancel out. And then this and this will also cancel out. So in the end we moved this part. So if you two-stage risk curve, then it becomes identical to the instrument variable equation. Right? So for your homework, that's why I suggest you find more than necessary instrument. So for your instrument variable equation, all you need is just to rank one of the it is up to you. So if you found 23 factors, so you can regard maybe 2 factors as Q and 1 factor as X, or you can regard 2 as X and 1 as Q. And